All right, in this module, we're going to talk about modeling and simulation at a very high level. So we're going to try and define it again, probably for you. You've probably had it defined before. But I want to kind of bring this back into context for the next thing we're going to talk about is actually the profession of modeling and simulation and what that actually means in terms of what you now have when you have your certificate completed. So one of the questions you might ask is, what are you asking this for now? I'm just about finishing this whole program, and now you're asking me to, what modeling and simulation actually is. Um, there's a good reason for this. If I'd asked the question of what is modeling and simulation way back in your first course. Now, some of you who have already been working in sim shops and have been doing simulation maybe for years already would probably have a really good answer, at least a good answer from your own experience on what you think modeling and simulation actually is. And I doubt very highly that I would disagree with you. But we have other people that haven't been working in modeling and simulation very long, and maybe they want to be, or they're just getting started, and you really don't know what you don't know yet. So I like to ask it at the end. It's actually good to ask it at the beginning and the end, and just see how your definition might change after looking at some different things. In fact, I really could ask this question both at the beginning and the end of this course, with my hope being that your definition of modeling and simulation will be somewhat different in 10 weeks than it is right now. So first of all, some definitions which hopefully you've seen before. We talk about a system, which is a set of connected things or parts that form some complex whole. And usually the complex whole is more than just the sum of the parts. So, a system could be a person, could be a group of people, a sensor, an aircraft, a platform, anything like that is what a system might actually be. A model is a simplified representation of a system intended to promote insight understanding of the real world system. So the key thing is that it's simplified. I'm going to come back to this in a second because this is really fundamental to what we are as modeling and simulation professionals is we model and we simulate the real world, but we have to acknowledge the limitations of what we are modeling and simulating so that we understand what conclusions we can and cannot draw from our models and simulations because we're the ones who built them. Okay, and then we end up with simulation, talking about the manipulation of modeler models in space and time, which requires some type of context and interaction among the models. All right, so just for reference, I like to point this out, not to depress you too much, but it's really the reality of our world. What I'm showing you here on the left is if that represents some physical artifact. Just think about something from your world. It could be a device. It could be the flow of blood. It could be you name it. Any physical artifact in the real world. And then you think about all the sensory stimuli that are included in it. What does it look like? What does it smell like? What does it feel like? How does it respond under different conditions? Are all elements of the sensory stimuli that are associated with this physical artifact in the real world. And what I'm showing you on the right is the exact same physical artifact, the very best simulation that money can buy of that particular thing. Notice it's quite a bit smaller. Which is exactly my point. The very, very best we can do in simulation is typically a tiny, tiny subset of what you can get in the real world. What is the implication of that? The implication of that is that it limits what we can say about what we know of what we learn from using our models and simulations because they are so limited. And part of what makes us modeling and simulation professionals is that we have the skill set to understand what the limitations of those models are and to guide our leadership on what they can and can't conclude from the use of our simulations. You can imagine simulations being used for all sorts of nefarious purposes and people drawing all sorts of conclusions from them that they have no business drawing, but the modeling and simulation person should know better. All right, so that's a big part of what I want to get across here. All right, so M&S in DoD and VA medicine and healthcare. First of all, we're very training focused. It's not unusual for our entire cohort to be entirely focused on the training domain. Both individual small teams, full and part task, some having to do with skill acquisition and sustainment. So you get a lot of virtual reality, augmented reality, different types of implementations, lots of mannequin simulators, maybe some mobile thin client type simulators, all those sorts of things. We've just been seeing loads of that. That's typically really in our crank house in this particular program. However, I want to talk a little bit more about some other topics you may not have thought about that are most definitely within the domain of DoD, VA, medicine, healthcare modeling and simulation. So AI-driven healthcare simulations, so machine learning for sorts of predictive modeling for looking at disease progression, patient outcomes, the use of generative AI. Think about the use of Gen AI as virtual patients, those sorts of things. AI-assisted surgical simulations. We're hearing more about digital twins are popping up more in healthcare. I hate that term for the reason of what I just explained because it suggests that the digital is actually a twin of the real thing, and it never is. But again, a digital twin with its limitations, if we understand them, in looking at hospital operations, physiology, all those sorts of things might make sense. Um, More computational disease modeling. We don't talk about this enough. This came up during COVID of all of the modeling and simulationists who were modeling the progression of COVID as it propagated through our population. Those are simulations. We don't often talk about them in this program because they're not training domain, but they are definitely the sorts of things that I think we should be talking about. So there's lots of other things, chronic disease progression, agent-based modeling for public health. Agent-based modeling, we'll talk a little bit more later when we talk about AI. All that really means is it's a piece of code that acts as an agent that can communicate with other pieces of code that act as agents. They communicate together and they interact in some way to form very complex modeling. In fact, we do complex adaptive systems are often agent models for that exact reason. So you can look at pandemic spread simulations as agent models as one approach to doing it. Looking at the impact of certain policies on a population or a healthcare system can be agent-based. So there's all sorts of different things that we can do with agent-based modeling. There's biomedical, biomechanical simulations, different 3D simulations of organs, prosthetics, blood flow, all those sorts of things that could be training related, but could also be operational. Looking at healthcare processes and system modeling. I know we know some people that are system engineers, particularly in the VA, that have used modeling and simulation for modeling the actual operations of a VA hospital for the purposes of optimizing it and sort of tearing it down and building the operations back up again in an optimal type of fashion. Those are all M&S systems. There's pharmacological and drug development simulations. We don't get into that really at all here, but there are whole programs. Modeling and simulation is deeply used in the pharmaceutical industry. There's robotics and autonomous systems in healthcare, so AI-driven robotic surgery, autonomous healthcare systems, all sorts of robotics that might have a healthcare application. And then lastly, talk about wearables and IoT is Internet of Things. If you think about maybe a smart switch you might have at your home that can talk to your Alexa that's an IoT device. It's got what's called an 802.11 chip inside of it, meaning it can talk on your local internet wireless network. But it doesn't do a lot. It does one thing. It knows how to turn itself on and off. That's what it knows. So IoT devices are meant to be extremely limited, but low cost and prolific. So a lot of those have applications in healthcare and medicine. Okay, so now I want to talk a little bit about what we call this is the modeling and simulation body of knowledge. This was first published in 2008, um, and I still talk about it because it really hasn't been refreshed in any meaningful kind of way. But it was the only attempt that I've ever seen of the modeling and simulation industry, and I don't just mean in medicine and healthcare. I mean the entire modeling and simulation industry, trying to get its arms around what it is. Because lots of people would ask, "Yeah, I heard about modeling and simulation. I don't get it. What is it? What do you do for me that other people don't do?" So this was specific to defense modeling and simulation, and I'll point you to the document on our LMS. It had input from across DoD, and it was sort of mapped awareness levels, like how much do you need to know in the different services and the different types of jobs that people might have that touch modeling and simulation. So it wasn't just an inventory, it was sort of a wish list of if you're an engineer of this type, this is what we think you need to know and at what level. So here's just a quick snapshot of what it looks like in the document. So here you talk about modeling concepts. So process models give you a little description of what those things actually are. And then here you get the awareness levels of ratings on all the different services. And you can see this is really coarse, right? So even inside of medicine and healthcare, the Army and the Navy and the Air Force might not agree. And you can look on this particular example, look at the ones and sevens. So it's across the board, the exact same topic. One service will say this is really important to us, and others will say this doesn't apply at all. So there's a lot of very interesting disagreements in what M&S is and what we actually need to know. So, but just to give you a quick inventory of what the key knowledge areas that appear in this document, modeling concepts, so types of models, representations, and processes, the building of models, the process of building them, LVC is live virtual constructive, which we'll talk about shortly, different types, DES is discrete event simulation versus continuous types of simulation, agent models, different types of knowledge engineering. Then at a management level is strategic planning, requirements procurement, all the dealing with the DoD, which is part of our course too. Then there has to do with development, so system integration, system architecture. These tend to be software or computer science types of topics, or information technology sorts of topics. Um, Something we're going to talk about, verification, validation, and accreditation, which doesn't get talked about enough because it has to do with when you build a model. We just talked about it's a tiny subset of the real world, but you built it for a reason. And you built it to be able to, so that you can ask certain questions of this particular model. VV&A, first of all, asks you whether it succeeded in doing that, and then it asks you to put some bounds around it. Because one of the things we always want to do in M&S is reuse each other's models. Well, what if I take your model, which was properly VV&A'd for your purpose, and I try and repurpose it for something else? Is that appropriate? Maybe yes, maybe no. But that's what this is all about. There's a lot about mathematics, statistics, probability. You studied a little bit of that in an earlier course. Certainly some computer science, and quite a bit about interoperability. And I'm going to try and bring your awareness up on this a little bit in this course, because we don't talk about interoperability really much at all in this certificate, but you should know in what we'll call mainstream M&S, this is an absolute essential, one of the only topics, this being this and VV&A, that M&S professionals care about, but almost nobody else does because it's unique to us. So we'll talk about this in a little bit more detail later, but it has to do with how one simulation can interoperate with another when they may not have even known about each other at the time they were being developed. So that is a snapshot of what modeling and simulation actually is as defined by lots and lots of other people, and we'll be talking about this more a little bit later.